Hello, everybody. Welcome to the September New York JavaSIG. Welcome back after our nice break in August. Hope everybody enjoyed. Let me see, summer's over what? Saturday? We have 3 more days of summer left. So tonight we have 2 talks from people in the JavaSIG in our local community. So this is awesome. This is the first time that we've had people from two different speakers from the JavaSIG. We have Victor and Neha. But just a few quick announcements. I mean, so everybody heard about Java 23, okay? Everybody knows that Java 23 is out now. Another announcement is that, so next month we're meeting at Microsoft's office in Times Square. So we're not gonna meet here, we're gonna meet at Microsoft's office. Neo4j is gonna speak about using a graph database with Java for AI applications. So that'll be interesting. And they're paying for the pizza, so that's good. But for that meeting, when you sign up, we're going to ask everybody a question. And I know, Barry, we were talking about this, Barry, about how do we get more, what are the problems? What are the problems? We want to get more collaboration with the community. You know, what are the hot button questions? Like, how do we get like more women into coding, into programming? Certain what topics should we talk about? I think Gene had an idea about having not workshops, but small meetings on certain Java topics, like a half-hour meeting on Zoom. Like here's a talk, a half-hour talk on records, or here's a half-hour talk on some specific Java thing. So at least we learn about the latest in small things. So if you have any ideas, so we're going to have a mandatory question. So when you register, I know you can say like, oh, so listen, it's just for the benefit of the group. Like any ideas that you can give us that to help improve or enhance the collaboration with everybody. I mean, we're a community. We should be helping each other out, right? Okay. Any other announcements? Anybody submit a paper to DevNexus? DevNexus is April, right? Or March? March? Right, so DevNexus is, I guess it's the premier Java conference at this point, right? Certainly in the US. And you should submit a talk. As I was saying before, that's the best thing that you can do for your career. Is that you can be the best Java developer in the world, but if you can't communicate your ideas to other developers, there's gonna be somebody else that can do that. So it's best to enhance your communication skills. And what's the best way to do it is in front of a friendly audience, so fellow Java developers. So try to submit a paper, even like we were talking about, do a pair presentation, do 2 people doing a talk on some specific Java thing, or what you did at work using Java that other people might be interested in. And the good thing about DevNexus, besides the cool people in the Atlantic Jug, is that they pay for the hotel in the air. So that's a big advantage. Okay. Yeah. Yeah, we have a group of 6 people that have done this for a long time, so we're open to give you any suggestions. Okay, so our presentation. So I'm gonna turn it over to Victor, but people that don't know Victor, Victor's a longtime member of the JavaSIG. Victor was our liaison way back when at Credit Suisse. I mean, you were very responsible for introducing us to Credit Suisse, so thank you very much for that. Also, Victor being a Java champion, which is a pretty lofty title. I mean, it's pretty cool. And you also have a JSR, right?
I had a JSR.
Had a JSR, okay. Also, it was concurrency animated, if I remember correctly.
Java concurrent animated.
Yeah, which was a phenomenal way of visualizing concurrency. That's like when I first saw that, I go, "Wow, this is so cool!" It's very helpful for me to understand it, and then for me to show other people how to understand concurrency. So let me turn everything over to Victor.
Thanks a lot, Frank. So do I need to share, right?
Yes.
And I have to thank you, Frank, because I've been at Bank of New York for about a year now, and I wouldn't have I wouldn't have arrived here for you and your introduction. So very grateful to that. So I think it's over a year since Java 21 was introduced. And to me, it's like it was the most groundbreaking release since Java 8. And the reason for that is because of virtual threads. So they had Project Loom, and it was incubating for a few releases, and then it was finally released in 21. The thing that's special about it is just the threading model. So in the olden days, before Java 21, if you wanted to do any kind of reactive development, if you want to do multi-threaded development, you kind of had to bake the reactivity into your code. And what virtual threads have done is they've abstracted that coding away from you having to do it, and it just does it for you under the covers. So what it really does is it takes away a lot of the overhead that's normally associated with threading. Switch the
Get rid of that little header up there.
I don't
Oh, I
see
can
it.
get rid of that for you. Here we go. Oh, you know what?
I probably can I
I think I have to get rid of it.
Oh, I see it. I
Oh,
see it.
yeah, go over to more,
3 dots, yeah.
and then hide the video panel.
I can't see it.
Or
Is that,
hide floating meeting.
am I on it?
Go down one.
Get moving there.
Click.
Great. Okay. Where's my slides?
Victor, somebody on YouTube is asking, can you share the slide deck?
Yeah, I'm going to do that, except
No,
someone
I
just-
think what they mean is. Oh. The sharing
Yeah,
stuff.
I stopped it because my slides, my whole deck went nuts.
You don't want your deck to go nuts.
No, I don't. So let me just close it. Hopefully whatever's there won't. Sorry about that.
I have a technical difficulties beyond our control background. I should show that.
Yes, you should.
You're still going to have to share your screen.
I will do that. Sorry for the delay.
Looks good. And I think, by the way, that the question from the YouTuber was, can you share the deck
I will
so
do
that it's available for people to
definitely.
download?
That's the one. Okay. So we know that when you're creating threads, this is pretty much what you do, right? You create a new thread, you pass in a runnable, and you call start. But did you ever want to do, why doesn't this work? did you ever want to do this, where you actually say thread equals thread start? I know I always wanted to do that, and you can't, but now you can. So the way it works is that you say there are two different kinds of threads now. There's traditional threads, which are called platform threads, and there are virtual threads. And the model now is, of course, the old way of launching threads still works, but you can now say thread of platform, and that will create a new platform thread. And then it uses a builder model. So in this example, we're saying start. You could also say, give it a name, you could give it a priority, all in that builder model. And you say thread of platform. And then you supply a runnable, and you say start. And that returns a thread object, and now you have access to that thread. You can also use the same model to create virtual threads. So you just say thread of virtual, and that will create a virtual thread. And as I said, you could pass in a name, you could pass in a priority. You can't pass in a priority for virtual threads because virtual threads don't have a concept of priority. But for a platform thread, you could pass in a priority, and you could pass in a name. You can also launch a virtual thread by using an executor. The executors, there's a new method called new virtual per task executor. And when you submit, that will submit using virtual threads. Okay, so what is a virtual thread and how does it work? So let's first, before we talk about that, let's talk about platform threads, the traditional old-fashioned threads. So platform threads are regular threads. They're assigned by the JVM, and they are assigned to an operating system thread by the JVM. The thread scheduler does that work of mapping them. And once that platform thread is mapped or assigned, once the virtual thread is mapped to a platform thread, once a platform thread is assigned, it stays with the operating system thread for its life. So if that thread has to sleep, or if it's waiting for some IO or something, that thread is dead, right? It's just basically out of commission, which is unfortunate because these threads take up a lot of resources. Platform threads are generally expensive. There's a few milliseconds of startup time for each one. There's time for context switching. There's memory assigned for each one. So platform threads generally are going to be resource intensive. There's also a limit to how many platform threads you can have because they're assigned so many threads to an operating system thread. So you always have that limitation. And like I said, when a blocking operation happens, like an IO operation or a sleep, the platform thread is just blocked. So all of those resources are just not available for creating new threads. Okay. Some of these limitations have been removed from the new virtual threads. And the way they work is a virtual thread is just a Java object. It doesn't take any more resources than a string. It's just a plain old Java object. When it's created, the thread scheduler mounts it to a platform thread, to a Java platform thread. And then when it comes to a blocking operation, like a sleep or an IO, the platform thread the virtual thread is parked, and the platform thread is unmounted. So now that platform thread becomes available to process other virtual threads. So you basically have an unlimited pool of virtual threads that are being handled by by a finite number of platform threads. And now this virtual thread is waiting for the IO operation to complete, or waiting for a sleep count to tick off. When that finally happens and all of the bytes have been returned, then what happens is the scheduler now reassigns that virtual thread to a new platform thread, probably a new one, and then it can continue and carry on its work. The most value we're going to see from a virtual thread is going to be any of these kind of IO bound operations or blocking operations, sleep, not wait. Wait will not benefit because of certain considerations. If you have a wait, you're in a synchronized state. When you're in a synchronized state, the underlying thread is competing with the virtual thread. So I guess they couldn't deal with that. So they just left these, when you're in a wait operation or in any kind of synchronized operation with a virtual thread, things are going to go a little bit awry, and we'll do some experimentation. We'll actually see some code to demonstrate that. You know, I showed this to somebody and they thought it was the signature of the method. This is the sleep method implementation pre-Java 21. So you see it was just a native call. You waited for the number of milliseconds and it came back. And the thread scheduler would take care of waking it up when the time was ready. Now that has been all re-engineered to do it in the virtual thread way. So this is the exact same method, and you see that it has an implementation now. And I'll talk about that implementation, but we see if the current thread is an instance of virtual thread, then we call this method called sleep nanos. And if it's not a virtual thread, then we just call the same old sleep method, which has been renamed to sleep zero, which is now a native thread. You can see on the bottom, it's just a native method call. So platform threads work the way they used to, which is just being controlled by the thread scheduler. Virtual threads do a lot more work, and we're going to look at that now. So when you have a virtual thread and you call the sleep operation, and the same logic is applied to IO operations, then it goes down to the park nanos method, which is where the thread scheduler will take that virtual thread and it will park it, it'll unmount it from the platform thread, and it'll just wait until the time is up or until your bytes are available. You know, one question that people have asked is, what do? You want to use virtual threads, and you're using Spring Boot, and you have an application server that's being allocated by Spring Boot. So maybe you have Jetty or another application server. So the way you handle that is you have to, first of all, in your application properties, you say Spring Threads virtual enabled equals true, and that will tell it to start using virtual threads. And then you have to build some configuration. I'm not going to go into the details of this, but it's pretty standard. So for Tomcat, you do this. You have to return a factory, and Tomcat will automatically do all the work for you. Or you can, for Jetty, it's the same thing. If you have a Jetty server, you just plug in you plug in a bean, and Jetty will do all the work for you. Spring and Jetty will find that bean and will start creating virtual threads for you. And one thing we should talk about is pinned threads. So like I said before, as soon as you enter a synchronized block, a virtual thread is going to start having problems. It's going to start acting like a good old-fashioned thread. So it will stay pinned to its carrier thread. So generally what you want to do is you want to take away all of your synchronization and replace it with reentrant lock. Reentrant lock was introduced in Java 5 to replace synchronization. It's a little bit easier to manage. You can move your locks around. You're not inside of a synchronized block. And so the job becomes, now I want to migrate my code base to use virtual threads instead of platform threads. I have to go and take all my synchronized, replace those with reentrant locks. Okay, so generally platform threads, virtual threads sound like a great thing, but it's not a panacea. So pin threads can cause delays if you don't refactor your code base. And there was an article in InfoQ a couple of weeks ago where Netflix had migrated part of their code base, and they were seeing problems because they hadn't synchronized everything. I guess, when you have a multi-million line code base, it's probably hard to do all that synchronization. In our firm, we are very microservices driven. We're able to migrate some microservices. You don't have to do them all at the same time. That's a good approach. Another caveat is that although thread resources are conserved, you still have the memory considerations that are associated with your thread. So if you're using a lot of memory, that's going to be a bottleneck, right? So if you want to get the best advantage out of virtual threads and you have high memory usage per thread, you want to figure out a solution, either parking that memory, saving it, requerying from the database or something. Also, virtual threads, I haven't seen this, but it's been reported that in certain situations, they can be slightly less performant than platform threads. I know that the OpenJDK group is working on this to try to get that solved. It's negligible. I haven't seen any perceptible difference, but it's been reported. And as I said, work is underway to improve that. So virtual threads are a great way to handle high concurrency. If you make an application that just allocates threads and does work, you'll get a few thousand threads that are able to run concurrently, and then all of a sudden you're going to start seeing out-of-memory errors. If you do the same experiment with virtual threads, you'll basically can make millions and millions of threads, and you won't have any problem. And that's because the intelligence is built into their implementation to park them, as I showed in the code, which frees up the underlying platform thread to do other work. We're going to see an example of that. And the really nice thing about that is if you have web servers now or application servers that are fielding X number of requests, and let's say you have 10 containers because you have a high volume application, now all of a sudden maybe you can go down to 2 containers. And so that is certainly going to translate to saved dollars. So in summary, no thread overhead for creation, very scalable, high concurrency, and greatest benefit is for I/O bound processing. I just want to do some coding just to demonstrate some of this. My mouse. Let me share this. So I don't know if people have seen, Frank mentioned before, Java Concurrent Animated, and this is a really nice way to visualize what's going on with concurrency. You could see like the thing in the middle is just some kind of either mutex or some blocking structure. Generally, we'll add threads. So you see in a synchronized block, one thread could get in, and then another thread will wait until the first thread exits the synchronized block. And so this is a really interesting experiment because it's actually using the Java, like I didn't have to code any special coding to say, do this when the green thread is running, keep those blue threads back. It's just looking at the underlying state and it's rendering based on that state. So it's really showing you a visualization of what's going on in the Java. So let's look at what happens in virtual threads. So with virtual threads, let's create one virtual thread. You can see the code for doing that over here. Okay, so the virtual thread is on top, and in this case, it's virtual thread number 79. And the platform thread that's under it is called fork join pool 1 worker 1. So you see that a virtual thread is running on top of a platform thread. Now watch what happens when I sleep. The platform thread is just going to disappear. Remember this platform thread number 1, worker 1. Now it's in the waiting state. White is waiting, and then it sleeps for 2.5 seconds and comes back. Let's just do that again. You see it's reassigned. Now, what happens if we have a couple of threads? So you see that the top threads, the virtual threads will always stay in the same order. So the top one in this case is number 6, and the second one is number 7. Now let's sleep, and notice that, I have to remember this, I'm going to test you on it after. Notice that the top one has worker thread number 1, and the second one, virtual thread 7, has worker thread number 2. Let's sleep, so it's in the order of 1, 2. I'm going to sleep both of those, and when they wake up, let's see it reversed the order. And the reason it did that is because they both went to sleep for 2.5 seconds. The first one went first, the second one went second. So the second one was released right away, and it went to the first virtual thread. So let's just do that again. Now while it's sleeping, we'll add another one. You see that it picked up, in this case, the new one picked up worker thread 2. So the JVM, the thread scheduler, had to allocate worker thread 3. And we could keep doing this experiment like for as many threads as we want. You see that what's happening is that the platform threads are being swapped out. And as soon as they become available, they just go and the first available platform thread is available to the virtual thread. Just want to also just go through some code. You get the virtual thread. If you're a virtual thread, you get the virtual thread. It really acts just like a regular thread. And in fact, if you just use virtual threads and don't replace anything else, even your synchronization, it'll still pretty much work exactly as it does now. So the benefit is once you start refactoring things. I'm not able to see what I'm doing here. Okay, let's just look at some code, and I want to demonstrate this in all its glory. So what we're going to do is we're going to create some virtual threads. In this case, we're going to create 3 virtual threads. So we're using executor's new virtual thread per task executor. Then for each thread, we're going to create this runnable. And what that runnable does is, first of all, it's going to get the current thread. It's going to get the IDs, the virtual ID of the current thread, which we're going to display. And what the point of this experiment is we're going to sleep and run and capture the platform thread associated with each virtual thread. And then at the end, we're going to display it just so that we can see this in action. So we're going to do a loop, and we're going to do this 10 times. So what we're going to do is we're going to create a virtual thread, sleep, and then come back, and then just do that 10 times. And we're going to collect a mapping of the virtual thread to the platform thread, and then at the end, we'll display those mappings. So we're getting the carrier ID, which is the platform thread. Platform threads are called carrier threads. We're mapping it, and we're just spinning the CPU, and then we're sleeping. And let's run this code. Now this is IntelliJ. I don't know, it used to be perfect, but now it makes a lot of mistakes. So it's saying that I have an error over here, but I don't. I do not know why it does that. And let's just run this code. And what it's doing now is it's showing you all of the mappings. So virtual thread number 26 was mapped to these 5 worker threads, these 5 platform threads. Virtual thread number 25 was mapped to these. So you see they're the same ones, but at different times they were mapped to different things. Now let's just do an experiment, and we're going to run the same code, except we're going to synchronize. And now when we synchronize, as I said, these are going to be pinned. So you're, if I'm right and they're pinned, you're only going to see one virtual thread per platform thread, and you see that that's what happens. So again, you get a lot of benefit. It's a money-saving thing to switch over to virtual threads. There is a lot of benefit, but there is a lot of rework. You have to start changing all your synchronized to reentrant locks. But I think if you have a high volume application, you're going to definitely see large benefits in money and processing time.
Yeah. Red local, you showed at the beginning of your talk sleep, but how does thread local work? Do I need to do something different with it?
No, it's everything works just the way it would before. And in fact, like I wanted to, when I was writing this, I wanted to get the actual platform thread from the thread. It's all so hidden underneath the covers and the modules that you can't even get the virtual thread. The only way I was able to get the platform thread was by calling toString. And when you call toString on the thread, it gives you the name of the thread and the platform thread. So I was able to use some regex and drop that out of there. But everything works exactly like it did before.
If you are having an operation like a sleep operation, it's a very good advantage, but if it's a wait operation, it's not advantageous.
Right.
So can you is it right to assume that waiting for result from DT is a wait operation, or what kind of operation?
No. So the wait operation is actually a call to the wait method, object.wait, and that always has to be done inside of a synchronized block. So the problem is not so much the wait, it's more of a problem of the synchronized, right? So you can't use wait inside of a reentrant lock. So part of your refactoring is going to have to go and change all of those calls to wait.
Someone on YouTube wants to know if you're going to be able to share your slides.
Yes,
downloadable.
Yeah, I'm going to
where
hand
can
that
they
off
find
to
them?
you.
Okay.
And any other questions?
Oh, what? Here we go.
So Victor, you mentioned that to enable like Spring Boot application, you need to put something in the application.properties.
Yes.
So along with
That's
that,
if you want to refactor it so that the application server will use virtual threads.
okay. So is it required on top of the Tomcat factory that you showed?
Yeah, so you want to, first of all, say use virtual threads, and then you want to create a factory bean so that Tomcat understands that if it component scans that bean, it will use that factory as a thread factory. You reminded me of an interesting point, though, is that they don't have an executor. You don't have an executor, you have scheduled executors, and you have all different executors, right? They didn't re-engineer all of those to work with virtual threads. So you have to like do a little coding for that. And there's ways, I have an example actually. I'm not going to show it now, but there are ways to tell each scheduler, each executor which factories to use. And you could give it a virtual thread factory. So that's what's happening under the covers with Tomcat or the application service Spring Boot.
Back here.
So any open source implementations better for virtual threads? Like you have Zulu, you have different flavors, right?
Yeah, I'm not sure.
So they all, the concepts underlying is the same, but I mean the various.
I haven't done any performance checking to see, but I mean all of these are based. I know Zulu is based on OpenJDK.
Yeah, Zulu is based on OpenJDK.
Yeah.
Then there's the Amazon version of it, right?
Yeah. So I'm not sure how they actually implemented it or what the differences are. Thank you.
Oh, okay, here we go.
You're not allowed to ask me.
Well, I'm curious, what's coming up in Project Loom now in the new releases?
Have to ask me the hard question. I don't know, I'm not sure.
Okay.
But I do know that they are doing work to tune things. So performance tuning, yeah, especially based on that article in InfoQ on Netflix. Was very interesting because there really was a lot of work that had to go into doing that refactoring. Thank you.
Thanks, Victor.
Thanks for
And now for our second speaker, Neha, if you want to set up your laptop.
Okay, that's gonna be a challenge. I might have to sit on the chair. Thanks for getting the chair, by the way. I know. Hold on. It's not because, you know, I have a special privilege. I think I have. Work on the other side, right? Oh, it's working.
Takes a little bit of time. There you go.
You should. Visible now to people. This is probably the weirdest thing I've ever done, like sit on a chair so that you can see my face. So,
Hey, I used to bring telephone books to the movies.
yeah, okay. Okay, thanks Victor for the amazing talk. I really liked it, and especially the visualization is really good. Very good. I've never seen it before. So it's a nice segue for Project Amber because they are both the important projects, I would say. I would like to call it important projects under JCP development. So I gave this title because, you know, it's fun. Making Java so easy even your boss will understand it. I literally gave this presentation to my boss so that I gave him the tool and he did probably understand everything. I have a stamp, the tool from him. Just a nice picture to describe why it is named Project Amber. It's because it's clear and see-through. So when you're writing a Java code, you want your code to be readable, you want your code to be concise, it should reflect what you are writing, your intent, your business logic should be really visible when you're writing it. So that's kind of the goal that reflects to Project Amber. A little bit of history here. So you know how Java releases used to come, like big bang release with a lot of jets and all the features were plugged into one, and then there was a gap year, 2006 and 2011, nothing came in. And then 2017, from 2017 onwards, it has been consistent, like every 6 months, there's a release, there are a bunch of features to try, some of them are previous features, and then, you know, every 6 months there's a release. So it gave a nice segue because, you know, if you know life before Agile, how different it was, and now the Java development had to adapt as well with the Java, with the real world, like be agile, more feedback, faster development. So that's how they did it. And this was the last 2023, 2024. So there were releases in March 23 for Java 20 was released, and then September 2023, 21 was released, and like yesterday, 23 was released. So pretty straightforward. So these are some of the key projects actually. This is not just Project Amber all about. So Java development process has many projects. Like Project Amber, I'm going to be discussing that. Project Loom, Victor already gave you a preview. And there are several other projects also. They have different goals. So we are now going to be focused only on Project Amber, but there are other more important work as well being done by the JCP. Now let's look at what our Project Amber goals. So the one most clear goal is to boost your productivity. We as a developer, we have to write the language, we have to use the language, we have to use the feature. And it gets really annoying when you are restricted by some language constraints, especially in the competitive world that we are in right now. Like if you have been working on Python, you're always like, oh, Python is so easy, so fast, you can write your code really good, and you can get started really quickly. And that was mostly the complaint that everybody gets about Java. Like we have been writing Java for 15 years, but if you ask somebody who's new, they kind of feel like, oh, that's too verbose to write a main word, hello world, right? A main method is too verbose. So the project goal came up with like, we should cut that short. We should actually maintain the language consistency. We should improve the code readability because a lot of times you're just reading code. You're not even writing code. You're reading other people's code. And if you not understand other people's code, it's bound to create more and more bugs for yourself. And Java is actually ongoing. So supporting a long-term evolution is also necessary. So we have to be up to the standards of where the industry is moving. So that's the most important goal here. Like I said, why it is important? It has a huge impact on developer productivity. It has more impact on code readability. You are kind of trying to express yourself. You have to show your clear intent. You cannot have bugs in your code. But in order for you to avoid the bugs, you need to be able to write the code in a concise way, which can pop up your bugs. You can easily look at them. A bit about myself. I'm a toddler mom. My daughter is 2 years old now. I keep complaining about it to everyone who's here. They know me. I also work as the vice president at Morgan Stanley Bank. Been in the Java world for 15 years now. I co-lead the Java user groups here in New York and New Jersey. I'm also part of the Java in Education program at JCP. And apart from these things, I do find myself enjoying traveling, yoga, and talking about it. So you can find all the links here. You can scan it. I'll also post it later in the chat, so you can have all the links. And the GitHub code, which I will be showing you, is also available there. I'll give you all the links. Before I begin, I want to thank the team as well. These are the Java users here. Not everyone is here, but I want to thank all the people who are made it all possible. And I really like the community here. So for me, it's going to be really, really this is from starting with Java user group. Oh, sorry. Give me 1 second. Can you hear me fine? Hopefully, yeah, okay. This is from the Garden State Java user group. Again, missing some people, but just to emphasize the point that the community is really vibrant in Java and which makes Java language more and more successful. Before we begin, actually, we want to share some important information which is pretty relevant to Project Amber. We will talk about JEPs and the preview features a lot in the next few slides. So I wanted to have a slide just for the introduction of what is a JEP. JEPs are Java enhanced proposals. So basically, you can call them as if you work on a Jira, it's like an epic story, or they are like the task that you are working on. So it's kind of that in a shorter way. Preview features are experimental feature. Beware, they are very much opt-in usage. So you will not have it just because it's released in a preview feature. You have to actually forcefully opt in them. And they're evolving design. They change it, they enhance it. Sometimes they
remove some stuff. They make changes to it all the time. So take it with a grain of salt that when you try to learn them, they might have a different goal or design in the next preview feature if they are going to continue with that. And how to enable, I can show you in IntelliJ, you have some options. If you go to your, this is a Maven project, but it's very similar in other projects as well. So you can enable them in here with an enable preview. You can also enable it in your project settings here. If you open the module settings, you can just, I think it's here. Yeah, so you can enable it and pick and choose which one do you want. That's another way of doing it. And if you use command line, you have to kind of force it with JavaSIG and all those things. You have to use this tag and then mention the number or the version number that you're using. Okay, so I have categorized Project Amber features into several categories. So it's not based on JDK 10, which one version had, Java 11, which version had. No, I want to build upon it. So you'll see me in different categories of versions. All of the versions are available up in 22 and 23 also. So you can actually, if you're new to Project Amber, just start with 22, and that will get you all the features automatically. But yeah, let's start with the first one. So the first category I have is the foundational enhancements. This is a pretty simple feature. If you have worked on other languages like Python or Scala or Kotlin, you have seen the var statement before, you have seen the var keyword before, there's val as well. It's kind of tricky in Java because it's not the same thing how it works in different languages like Scala has. I know Scala better than others. So I know Scala has a very strong type inference, which is not the same case. You might end up with some unexpected errors. So use var very carefully because var can have unexpected changes as well. But var is simply telling your compiler that you can replace this big keyword that you have with a shorter keyword called var, and I'll give you an example as well. So if you go here, so you can use, like, if you are returning a list of cities here, you can just replace it. A most common usage I've seen using var is in test. When you're writing your test, it's easier and more maintainable. So it's kind of easier to write it there. And you can see in the for loops, enhanced for loops also, you can use it in the try as well. But some of the invalid usages are like you cannot have it in the method parameters, or you cannot have it as a return type. And if you try to use it at a class level, like a field method, it will a field variable, it will not work. That's not allowed. And you cannot just uninitialize it and just keep it lying there. The compiler has to know which type of object you are trying to create. So nothing has changed. Java is strictly typed. It has been there from the beginning. It's just the ease of writing in some cases that you can use var. And similarly with var lambda, it's just a ease of writing it. When you are using lambda expressions, you can just replace them and use var here like you have seen. And especially it kind of shortens your code when you are using annotations like here. So that kind of eases it out. The next category is the data handling simplifications. So you have seen it before now. So records were introduced in 14 and they were carried out till 16. So they were introduced as a preview feature. They did some enhancements, they got some feedback, and they finalized it in 16. And that's what it means. Records are simply a data class. They are immutable, they are final, and they are very, very good for your data transfer objects. So whenever you are using a POJO, you are doing entities in your project, right? You have entities where you want to carry some data in and out into your applications, and records are pretty much a very useful case in here. I'm going to show you example once I talk about seal classes as well, because it's going to combine. So then it came seal classes. So seal classes are, it's like sitting on top of records. So you are created a hierarchy. You always have somewhere in your application when you're designing, you have super classes, and then you are defining subclasses, the child classes are there. But at times you are trying to wonder, like you want to restrict the inheritance. It's not like inheritance is gone. It's the oops principle. It's still there, but you're trying to control the inheritance in the cases where it's not even possible to extend. And I'll show you an example as well. So in order to control your inheritance, you're using a seal class where you are actually having a permits keyword where you can define, okay, this is my super class and it can only extend these 3-4 classes and nothing else. And if somebody tries to do it, it will cause a compilation error. So it will not be allowed. And that gives you more functional way of designing your application. So when you're data modeling, you are aware of the possibilities that, okay, this is my object and this is the only 3 types allowed for an object to have. So that's kind of, it's built in code safety, and it works really well with pattern matching that we will see again. Let me show you the example as well. And these are all the examples I have written in the GitHub, so you can actually see them. Here, if you look at my payment engine, so I have a sealed interface, which is a payment method, and it says permit only credit card, PayPal, or a bank transfer. So I have defined records with a credit card, a record with PayPal, and a bank transfer. And these are my all possibilities. If somebody tries to create a new record with something else, it will throw a compilation error and it will complain about it. And you can write your own implementation. Like I have defined a method here, which is an abstract method, process payment. And then I can just write my own implementation in my record and just use it in my main method to create different types of payment methods here. So it works where I haven't shown in the example, but if you use a switch statement, a switch expression, you can actually, there's no need to have a default clause because your code is aware that many case labels exist and nothing else. So your compiler is getting smarter and your bugs are getting smaller. So the next one is the text block. So I put this in the data handling part because it's also something which is related to your data manipulation or string, basically. For example, when you were writing a long strings, I hope you remember how much painful it was to write it like this with escape characters and plus and all those things. I really remember those days and I literally don't want to go back to that time. So this is where it came in. So now you're looking at the goals of Project Amber and it said that, oh, you want a code to be readable. You don't want those ugly syntax and plus and escape characters. You just want to read the code, what it's doing. So if you look at simply, it says, oh, it's a JSON and it has these values in it. It makes your life easier. So which makes your boss's life easier. And that's why he would understand and make yourself happy. So it works that way. Yes, please.
You can see that make it uniform with Microsoft, where they use, I think, @ sign and then quote for strings, multi-line strings. If you go back to the previous slide,
Sorry.
instead of using 3 double quotes, using like whatever they use in .NET.
Oh, okay. Well, you're asking me why they chose 3 codes? Or
Yeah, no, yeah. Did it ever occur to anyone to maybe just unify different platforms, use the same thing that the other platforms?
I would say it's a little tricky for Java. I agree, and we will see that in the next example as well with string manipulation, what happens. So just hear me out for next 5 minutes because there's a lot more coming. So this was, sorry, yeah.
a specific example, line number 17,
Mhm.
are the spaces are there or not? When you look at inside this string, do you
Mm.
have the space, all the way the indentation, right?
Yeah.
Does it internally create bunch of spaces?
I think no, it doesn't internally. You see an invisible line here. It's sort of, do you see a line here?
Between the line and let's say line and A.
There's no space here between the line and the bracket starting here. Yeah. You mean this one? Hmm. Yeah.
Because that was sent by a close in 3/4. It's then.
Yeah.
Close will be essential for Java. Just before the close in 3/4 will be removed from line.
Okay. Yeah. Okay. Yeah, we are actually short of time as well. So let's move on and we can discuss it after the presentation. But yeah, I mean, it's automatic formatting for you, the text blocks. The second one that's I'm discussing is the string templates, and that's where things get really different. So string templates are something which I think you are talking about. Where was that person? So string templates were like, the long sequels with concatenations and all those variables in between, which were sort of invisible that you didn't even see with it. This is where the string templates came in. So we used the text blocks to use the formatted and injected the variables here, like here in this example. But string templates, if you have used Python and Scala, they're pretty cool. And I really love it. And I was so disappointed that it was removed from Java 23. But I think the reason that was removed is because there has been, they want to make it right for it to work with everything, and the format is going to change. That's what I've heard. The syntax will change in the next versions. Hopefully it's coming back. That's what I think, because it's clearly a feature that every Java programmer must have wanted. At least I wanted since I started using Python and Scala. It's a really cool feature. You can inject your variables. It's not the same as what you see in Scala and Python, but it's close enough. And I think it does what the job is for string templates to be done. So, and I think it's more powerful. They are very, very powerful. You can create your own custom string templates. So that's why. But I agree. That's one of the reasons why I've put it here in bold, that it's not available in Java 23. So I have to actually remove everything I've written in code and make it work for Java 23 for this to work. But yeah, it's a very simplified string concatenation, and it's really readable, and it's cool to work with. Actually, one of my favorite features. Yeah. I think so. What I've read from the blogs, it was removed because they found an issue, and technically they did not have a full amount of time to actually fix it. So they, rather than bringing something which is unsafe, they rather have not released the version. So that's what they are. But I'm hoping it will come back. Okay, so the next category is the control flow improvements. And this is the major category where all the features came in. So you saw the preliminary things like records, sealed classes, text blocks. These were like the basic building blocks, and the control flow improvements were built on top of it. The first one is actually, it was released in Java 12, which was pretty earlier. And it was a switch expression, very simple. So we used to have switch statements, and switch statements created a big problem because first of all, when they were launched, they were not compatible to use with many objects types. And it was like, you have to add breaks, and then you have to remember to add break statements, because if you forget it, it will flow through and will go to the default, and you'll get a call from your manager that there's a bug in prod, and you'll like run around trying to figure out where did I miss the break statement. So, and it was all doing the same thing, like you use a switch statement and then you'll assign a variable and you will return the variable. So it didn't make sense to not have anything, and you would end up either using if else, which is really panicky. Not a if else fan. I'm not a if else fan, but so they introduced switch expressions, which is easy and readable, and it yields a value. If you have multiple lines, it will yield a value, and it's good for exhaustiveness checking as well. So let me show you the example of that as well. So we have control flow and you have switch expression. So it's a pretty standard example. So you have case labels. Here you can see I just don't have any breaks and I have a default case. But if I'm using something like seal class or records here, I don't even need to have a default, because the compiler will know, okay, these are the only permitted classes there. So you don't need to have the default. And all the examples are actually in here as well. So you'll see. The other one is the pattern matching for instance of. This is also another case where you would have to cast an object. So you are checking the type of the object. If it's a string type, let's say, and then you would add a brackets and then you cast it into string and then create a variable on it. It was unnecessary, tedious, and quite frankly, not readable enough. So it eliminates that, and you get a simple and easy way of just assigning your objects. It's a pattern variable here. So the scope of this obj variable is just still here. Not obj, str variable is just still here. So it's pretty easy to read rather than if you have this like here. And also because if this is just one if condition, you can have more than one if condition, like if you can check more than one types, and then you have to do some operations and it gets more and more complicated in that way. So yeah, so it's really easy to read. So building on top of that, so you saw we talked about switch expressions. We are returning some values, and then we added pattern matching instance of, where we are sort of reducing the casing here, sort of in a cleaner way. And then now we introduce the pattern matching for switch, which is actually simplifying the control flow. It's really, like I said, it really works with pattern matching. So we have an example here, pattern matching with switch. So pretty simple. There's a sealed interface called an expression, and I have a bunch of records, which is a constant or a negate or an exponent. So these are like operations that I want to do with an expression. There are different components. So you want to negate if you have a constant. If you have an exponent, you want to add two expressions. You want multiply or you want to divide. So it's all inherent. It's an expression is like a superclass, and then all the subclasses are here. So this is where we started to build the blocks. So when you are evaluating, let's say here, let's go to this part of here. So this is basically your evaluate method here. So this is your switch expression, where you're returning your value from a switch, and you are just checking your expression here, which is the case, the sealed interface. And then you are just trying to assign the values. So if it's a constant, you just return. If it's negate, it will just negate the values, and exponent will do the same, and all the other operations. So you can do all this. I've also used something which is an unnamed pattern, which I will describe later, but here's the whole idea about it. And in the main method, you are just creating the objects and calling the method. So here I created a 2 expression, a 4 expression, and a -1. and I'm just evaluating something here. Just evaluate -1 and it will assign and return your values from here. So if you notice here from line 17 to 24, there's no default or there's no breaks or nothing. So you kind of get the intent that I'm trying to do in a simpler way. So if you had to write it without the switch expressions, you will write some if-else conditions and all those ugly things, and it will make you sleep probably before you try to read it. So it's really important to show the clear content of your code when you're writing it. Then now the next one, since we defined the pattern matching for switch, it's basically a record pattern. A record pattern, again, let's look at an example here. So I have a record department and I have a record employee, and then I'm trying to create here a bunch of departments here. And this is my way of doing the filter here. So what basically is this lines are doing is it's deconstructing your records. It's opening up your records into pieces. So if you look at here, it's employee instance of employee and the name and the position. It's kind of opened up your filter here, and you can just break it down and map it here. If you look at the other example, that will also give you more depth. So here there is a record called circle and there's a record called rectangle. And with the shape, when you're creating a shape, you're creating like a circle with, let's say, radius 5. And then with you using an instance of, you're using a circle with double radius. So it's kind of mapping your values in here, and you can just use the deconstructed pattern here, which is a record pattern. So this is basically a record pattern here, which you're using. Sorry. Yeah.
In line 17, what are we doing?
So you're checking the instance of circle. So your circle is a record. It's basically when you're using a switch statements or you're using an instance of patterns. So you are just replacing your objects with records. So they are integrating your switch labels to use records as well. And that's what they are calling the deconstructed pattern. So because you're just deconstructing your records here. Why would it skip? Oh, okay, yeah, it would skip, yeah. We can try. I think you need to, yeah. You can actually do the other way. So if you're not using a radius here, let's say I just remove it. You can do the other way. So you can remove the variable and use like an underscore here. That will work. That's an unnamed pattern, which we are going to discuss later, but you still need to provide the type. I didn't understand your question really. Yeah. Yeah, but you have like, so if you see here, you need to have, so I still think because Java is strictly type, so you need to define the type everywhere. That's always going to be there. You can't just skip that, and that's just to avoid the type interference if there are multiple different types there.
If you leave out the double in the parentheses, then it would still match, right? It'll say it's an instance of circle.
Yeah.
So I imagine that if you have multiple constructors, maybe you have circle with a radius and circle with a radius and a diameter, and I don't know what else.
I will try that. Actually, I haven't tried that, but I will definitely try that with multiple constructors. Yes, that's a good thing. Oh, good question.
Question was, can you use a var?
So, but it seems like we can. We can use a var here. Oh, maybe because I have not defined the type. I have not used it, right? So if I go back and say radius here, and then add radius, the live coding. Yeah, var works. I'm learning.
Try add one more record.
Okay. So let's add a record line, maybe.
Okay. Circle.
Oh, you want to add a new constructor?
No, you can use the same name. It should be one more constructor.
Oh, sorry. You mean inside here?
You want to, you would have to like add
Something to the radius and then add another inside there another constructor that takes just radius.
Okay, we are really short on time. Can we try it later in the half? Because I would like to finish the next half. I just have 15 minutes left. But yeah, I can post all the examples on the GitHub code here. So yes, where I was. So we discussed the record patterns here, and we also sort of looked into the next segue, which was the unnamed patterns, and there are unnamed variables as well. So like you saw in cases where there is a language constraint that you need to have a variable defined, you are using those, you kind of have the areas where, let me show you with the example, because that's much more faster. If you look at the unnamed variables. So unnamed patterns I already showed you, right? So unnamed variables are also pretty tricky to find. So if you have like the first example, I like this one. So if you have a try with expression here, so if you have something like here where you are using a try block and then you are not using the variable here, it's kind of you still have to define the variable, but you're not using the name of the variable. So you can replace it with the underscore. And especially with the catch block, where most of the time when you write the catch, you're not really using the letter E and then writing it out, you're just handling the exceptions. So these are like common examples where you can use underscore and kind of get away with writing the or thinking about a name of the variable, which is kind of tricky always. And it's also used in Lambda. There are uses in enhanced for loop as well. So that's also quite possible here. So yeah. The other thing that we have come up with here is the new language features. The new language features are one of the most important things. So the first and foremost complaint that we always got was that, oh, Java is very verbose because you have to write the hello world with the big main method where nobody knows initially what the string args thing is doing inside, and then why are we writing it, and why is it always static, and all those things. So what introduced was a very simple main method, which is nothing but ultimately, okay, the new features, and then the unnamed. That's it. You just have no classes, nothing else. You just have the main method. And in Java 23, we actually don't even need to have this system.out. You just have the println and you just write it. Finally, finally we have it, guys. But yeah, but be careful, because this is mostly as a beginner, you just have like a freedom to express yourself. You write your Java code, be happy, be motivated, and move on with your life. And then you try to learn the hard ways. Oh, this is not the real world, but it's useful for small programs, but you still have to use the other ones for a big program if you have something more concrete implementations as well. So but I'm so happy that it finally came to Java. So I was so excited. So there are,
You've already implemented your own print line, and which one is going to win?
I think, so yeah, so that's a good question. There's a sequence. So if you have the original static main method, that's actually take precedence. And then you, if you write it this way, this is the least preference. So there's like 4 levels of it where you have, like, this is without a class. If you notice, there is no class here. It's the implicit class that's defined, and it's final implicit class. You can't write a package here. The package name is also missing. So these are certain constraints that you need to work with. And when you're writing a real, this is good for teaching purposes. I bet Barry likes it. But if you're writing the main Java code, like you are working in a company or something, it's you still might want to use the old version sometimes in that ways. But it's good for learning something in Java. That's always handy. The other one is the module import. So module import is introduced in preview 23. So I don't have the exact code for it, but I can just describe it. So it's basically when you have, when you import your packages, you have sometimes multiple packages, or you have multiple classes from the same packages. So you remember, we reminded you, don't add star to the end because it will import everything and it will create a problem. So there was a cleaner way of doing it. That's where you can import a module into your program now. So you can, if you know the module name, you can just import your module in the declaration, and that actually maintains your readability of the code and just still makes your life easier when you're declaring things. And it kind of works in the main method because I think they created a new package, which is the implicit package, where the reason that you don't see it here is because they added it to the java.base package and they imported it there. So it's module imported there, so kind of created a version on top of it. And that's why you don't need to use any of those static methods. But internally, it's calling the static method by default. It's kind of behind the scene work that way. The next one is interesting one because, so if you remember, I have a code as well. So yeah, let me show you from here. So if you remember, you have a superclass and you have a superclass constructor, and then you have a subclass where you are calling your subclass constructor, but always you had to call the superclass constructor because you had to initialize all the variables in your superclass first. But if you had to check something like anything within your variables before you are initializing, you had to create a static helper method because it wasn't allowed to do any validations before. And that created, like, it was tedious. It was, not really visibly showing the intent of the application. So one of the things that the Java architects have done is that you can actually call a method here before and do your validation. This is just adding a message and returning a message, but you can actually do validations of your variables that you are going to create. So basically, you are failing fast. So if there is any validation errors, you are failing at the very beginning before you are even calling your super constructor, and there's a failure or validation error there. So you can do some validations before here. So that's the new change here that came in. The last JEP, so this was up until Java 23, everything has come up and I've covered everything. But there's a new JEP which is in works. It hasn't been assigned yet, but it's kind of in works here. So it's a derived record creation. So basically, you have created records, right? You have a record where you are, let's say, creating any objects, but they are final, they are immutable, they won't change anything. Sometimes you have to inherit some values, like you want to take some of the same values from a record and want to create a new object. So what you will normally would do is like create the exact replica take all the fields and variables and just put it in the new record, which is kind of, if you have a big constructor, it kind of becomes a problematic thing. So that's where it's like deriving from the record. I think I have some code, but I don't think it will work. I hope I had some code which I created some sort of sample. So I kind of commented it out because it's, first of all, it might change. It's a new JEP. It's still being worked upon. So the syntax and everything might change. So it's basically, if you have a person, which is a record, which is an original person, and then you have an updated person, which is like deriving from the original person and with added some values here, like, you know, change some values here. So you updated your person with a new email, and, you know, you are reusing some of the values, just changing some values here and there. And then you can chain it as well with clause. But this is still work in progress, so it might come. I don't know when it will come, but it might come soon. I think that's all. I have some blogs for you to share. This is the homepage from Project Amber, which has all the latest information. I really like the blog from Nicola. Nicola is the developer advocate for Oracle, and all he talks about is Project Amber. So I really like his blog. His videos are really great in terms of understanding the depths of Project Amber and each of the new features. And then I have also written a blog which is on Project Amber, which covers features from 11 to 21. I'll update that to the new feature, but it has covered up until 22. So you can see all the examples there as well. And this is a nice blog from Brian Getz, who's the architect on Project Amber, and he's written an InfoQ blog on data-oriented programming. So all we are doing, the records, the seal classes, and the combination of everything is basically modeling your data, right? So everything is about the data right now. The applications have data-intensive applications, so you have to create your models accordingly. And so Project Amber comes really, really important, and I hope you read this and like them. All the code samples are here in this location, so you can check them out. They are updated, and I'll update more with the samples. Yeah, I guess that's it.
Great, thank you. So Neha, so I'll get the slides from you or the links, and I'll send them out through email so everybody has the links.
Yep, sure.
Then the same thing, Victor, with any of your stuff. Any last questions?
Can I come out of this chair, please? Okay.
Any questions? If not, we have our next meeting is at the Microsoft office, and you'll get the email invites, of course. And also, I wanted to thank Bank of New York. So thank you very much, Bank of New York, for hosting us tonight. So thank you, Bank of New York. And we'll see everybody next month.
I can't believe I finished on time.
Good timing.
But I got a good feedback. I'll create